go ahead and record it just in case
Okay.
anybody else wants to watch. But did you have like any questions on the material before we start?
I did. So, right off the bat, I was really just kind of struggling wrapping my head around point estimate and population parameter. And I think today I kind of finally decided that like point estimate was just um, a, a, an estimated value based on a polled population or a sample population um, that best represents the range of that particular population, where population parameter is really just the polling of a sample group to ideally represent the entire population that you can then identify a mean and a standard deviation from that.
Yeah, I think you're overthinking a little bit.
Okay.
I mean, population parameter is just a number that represents the whole population. So, I mean, in just basic terms, it could be mean, it could be the standard deviation. But yeah, it's just a number that represents like the whole population. But the point estimate is just taken from a sample. So if we have like several different samples, we're going to get several different means. You know, the mean of one sample is not going to be the same as the mean of another sample, and that's why they call it an estimate. So, I mean, basically one just comes from the population, which, you know, we can hardly ever figure out because you can't figure out the whole population of the United States. That's constantly changing. So we take samples, and each one of those samples has like a mean or a standard deviation, and that would be the point estimate representing the population. You know, how well does it represent the population? And that's a question that we'll figure out later on in the course. You know, is this sample a good way? There's ways to tell if a sample represents the population. So
Okay.
what you said is true. What you said is true. And yeah, that's basically it.
Okay.
Hi, Charity. Yeah, I didn't mean to interrupt. Sorry.
No, no, absolutely not. I think my only other question was, so it seems like there's a lot of variance in some of the discussions this week, and I think where some of mine, where I thought I was going in the right direction, but now I'm kind of questioning myself is, um, it says, let's say the data is normally distributed, which the example data that was given was skewed. So
Right.
we're assuming that we have a median or a mean, which is the centering point, and we're going to say, okay, 65.4% or 95.4% is between this number if it was that perfect bell curve. That's what we're
Yes.
supposed to be going off of, right?
Yes,
Okay.
not what we have, because you're right.
Okay.
Our data is not normally distributed.
Okay. Perfect.
So they're just, and I could talk more about that today. I was going to do an example in Excel in case people were still having trouble with Excel, and I can talk more about the empirical rule there. But again, the empirical rule is just giving you estimates, because we can never, you know, figure out the whole population. So it's just a quick way to tell us that if our data follows a bell-shaped curve, that we can say, or we can approximately say that 68% of the data is between -1 and +1 standard deviations, 95 is between -2 and +2, and 99.7 is between -3 and +3 standard deviations. But I can do an example of that.
Okay.
In fact, I mean, I can do an example right now since you asked. So let me say that if we have a normal distribution, we know that it's bell-shaped, and the mean is always in the middle if it's normal. And I can't really write really good on the screen, but I think with the rough pictures, it'll be fine. So the mean's always in the middle. And what it's saying is that if we go to the left 1 standard deviation and go to the right 1 standard deviation, that 68%, and the book I think says 68.44, but we're just going to use 68. 68% of the data is between -1 and +1 standard deviations. So that's approximately. But it's a good easy way to figure out things. We could just look at it and say, oh yeah, there it is. And like if you were looking at grades like A, B, C, D, and F, that would be 60. If you were to grade on a normal curve, it's saying 68% of the scores should be between +1 and +1 standard deviations. That's where the C's lie. So, if students ask, oh, do you grade on a curve? You really don't want to grade on a curve. Most of the students would be getting, C's. It's not to your advantage. If we do, again, if we go and jump in anytime if you have a question. I'm going to do a specific example, but okay, again, the mean's in the middle. We have a bell-shaped curve. If we move 2 standard deviations on either side, then according to the empirical rule, 95% of the data is in between those 2 values. So I'll just say approximately 95% of the data is in between -2 and +2. And then if we do -3 and +3, usually there's nothing way out there. So the most that you see is usually -3 and +3. There's hardly anything at the tails. So if we do all this from the empirical rule, between here and here, standard deviations, that would be 99.7%. So the empirical rule, just for a quick, anytime you want to look it up or anything, just remember it's 68, 99.7 is how they usually write it. Okay, so for a specific example, let's take a specific example. So, I mean, suppose you do have test scores or whatever, it doesn't matter. For this example, let's just say the mean is 70, and our standard deviation, when we, figure it out from our scores, I don't even need all our scores. Say the standard deviation is 10, and say it's normally distributed. So it will tell you that. So immediately, if you were to use the empirical rule, then you would know 70 is in the middle. Your mean's always in the middle. And if you move over +1 standard deviation, that means you're going to add 10 to the 70 because your standard deviation was 10. So that would be 80. And then -1 standard deviation, you would subtract 10. So that would be 60. So between 60 and 80, your scores, that would be 90. Oh, sorry, not 95. It would be 68. 68% of your scores should be approximately between 60 and 80. Or between 60 and 80 should be approximately 68% of your scores if, say, these were test scores. And then you could keep going and, let's see, you could keep going and then you could also say, let's see, -2. So we said the mean was 70 and then +2. So remember the standard deviation was 10. So 2 times 10 is 20. So you're going to move over to 50 here. You go 50 to the left. I'm sorry, 20 to the left and 20 to the right. So this would be 90 because it's 2 standard deviations, which makes it 20. So between the scores 50 and 90 should be 95% of your scores, approximately. So again, this is just an easy way to figure out, and next week we'll do probability. So you could say the probability your scores between 50 and 90 is 95%. So that's how it ties into probability. Probability turns out to be the area under this curve. And we're going to study that later, so I'm not going to get into too much depth. We're going to spend a whole week on that. So, you know, like I said, don't worry about it now. But what we know from the empirical rule is that we could just look at this and say, oh, yeah, 95% of our scores should be between 50 and 90 if it's a bell-shaped curve. And then one more, you could say between, let's see, our mean was 70, and we're going to go -3. And remember, our standard deviation was 10. So that's going to be -30. That's going to give you 40. And then +3 standard deviations, that's 30. Plus 70, that would be 100. So you move over 30 to the right. So that says approximately 99.7% of the scores are between 40 and 100. And again, how that ties to probability is that this area, the whole area under the curve is 100%. Okay, so if you're looking at a normal curve, underneath it is 100%. That's easy to see. I mean, it's everything's under the curve. So what this is saying that the area under the curve, 99.7% of the area covers the scores between 40 and 100. The probability that your score is between 40 and 100, you could say, is 99.7%. But again, we're not going to talk about that till next week. So that's all you have to really know about the empirical rule. That how you approximate the area.
Okay, thank you.
Well, I'm looking at the question though. It does ask. It does ask about our data, and even though our data isn't really, it says pretend that our data is normally distributed. So it is actually asking what percent of the values are within one standard deviation. What dollar amount range is one standard deviation from the mean? So actually it is asking that question. The ABC data. So you do want to find the mean of the ABC data, and then just add one standard deviation here, and then subtract one standard deviation. You want to do that in Excel, and then you will know that 68% of the data is between those two values. So actually it is asking for the ABC Enterprise numbers. So does that make sense?
It does. Thank you.
Okay. All right. Hi, Kimberly. Do you have any other questions?
I don't.
Charity? or Kimberly, if you just came in.
Yes, sorry, I was trying to. I thought it was a chat box, but it looks like it's gonna type on the screen. And I told you last week I don't learn well from the book for math, so sorry about
Sure,
this
that's
question.
fine.
So I did all of the formulas in Excel, of course, to get the mean, the mode, and the median. And I calculated the standard deviation with the Excel formula as well. What I'm not understanding is the minus and the plus one standard deviation. Is that I subtract from the mean 17.21 and add 17.21?
Yes.
Okay, that was one of the things. And then I had the question about the last part of the discussion as well, when it was talking about saying the data is normally distributed and the empirical rule. So we just add one standard deviation to the front and the back, and that's all we do,
Yes.
right? Okay.
Yes. Yes. So, like you said, what did you get for your mean?
Hold on. Sorry, I'm gonna mute the TV for a second. For my mean, I got 63.36.
Okay, so that would go in your middle. So again, when you're doing the empirical rule, don't overthink it. All you're doing is putting the mean in the middle. And I know our data is not normally distributed, but it says, let's say it is. Okay. So they're just assuming this. So put your whatever you got for your mean in the middle, and then what did you get for your standard deviation?
I got 17.21.
Okay, did you use the sample or the population one?
The sample, because we discussed last week that it was a sample because everybody wasn't surveyed.
Yeah. Okay, good. So you would just add one of those to the right, and then you would subtract one of those to the left. So you would, just like you said, you would add the 17 and subtract the 17, and that would give you 68% of the data is between those two values.
And that was the part that was throwing me off, the one of them. I was like, one of what? But it makes sense now that you explained it.
Okay, and then when you want to do -2 and +2, then you would just multiply the 17 by 2.
Okay, on both ends.
Yeah, just keep moving. Keep moving by a standard deviation. So there's one, there's another one. So if you said it was 17, then you would add that twice to get to +2.
Okay, gotcha. Thank you.
So I can do that in an example if I don't know your Excel's okay, or you're able to see. I just want to make sure I answer all your questions first before
I did so I opened up the get the ball rolling sheet, and so I just broke it down each step that you gave us. So I just made like on the tab 2, I added a spot for mode, mean, median, and standard deviation, and I just used the formula that you like. I sorted the data again from smallest to largest, and then I used the formulas that you had on the Word document, and just selected the data for each one. So I came up with 63.36 for the mean, 60 for the mode, 60 for the median, and 17.21 for the standard deviation.
Okay, so I guess the only thing I'll just do an example real quick of that, and then the quartiles and the percentiles, I guess I'd like to just mention how to find those. Just make sure you know how to do that, or everybody knows how to do that. So just stop me.
That was like the because I always do the workbook, or not workbook, but the homework, the first assignment, the one that's in the book first, because I can do the check my work feature to make sure I'm on the right track, and hit the hint guide a lot of times to make sure that I'm going through properly. So the quartiles were the ones where you like do 2 over however many the data set is and stuff like that, right? To get the percent. Okay, just making sure I'm on the right.
You can do it in Excel, and you're going to get different answers. That's the only problem, but it's still correct. They're both correct answers. So I I don't remember what answer they'll take, whether they'll take the Excel. I think they'll take both because the answers are really, really close. So let me just show you both ways.
Okay.
But I'm just going to use the same list of numbers I used last week. Can you see my Excel?
Yep.
Okay, so I'm going to first just find the mean. We always find the mean, so you're just going to type equals average. I don't know why they don't use mean, but they don't. They use average. And then you're just going to select. I have 50 numbers, so I'm just going to make sure I select all 50. And again, stop me if you have any questions. And then I'm just going to press enter. And I get, for mine, I get 35.24. So that was the mean. And to get that, you just do equals. If you look up here in the formula bar, you see equals average, and that's how you get that. Then you do the mode, or it doesn't matter what order you do this. So I'm going to equal mode. I just start typing mode. Now it might have two modes, so I just always like to use the multi. You can have more than one mode, but those numbers have to show up the same number of times. So like if you have one number that shows up 9 times and you have another number that shows up 9 times, and that's the most times of any number, then you'll have 2 modes. But if one number shows up 9 times and one number shows up 8 times, then you only have 1 mode. Okay, so it's the number that shows up the most. So I just picked multi because I'm not sure, but I select my numbers and I just get one number. So 37 is the mode here. That means 37 is the number that's used the most. So before I go any further, what I'm going to do is I'm going to take my list of numbers and I'm going to sort them from smallest to largest. Now, you didn't have to do that for that exercise, but I'm going to come over here to sort, and I'm going to go sort smallest to largest, and it will automatically do that. So then I can see 37 is used 4 times, and it doesn't look like any other number is used 4 times. So, okay, that's good. Then the median. Now the median, if you don't have Excel, I mean, we all have to use Excel, but here you would first you would put your numbers in order, which we did. And then since we have 50 numbers, we would average the 2 middle numbers. So since we have an even number of numbers, we don't have just one middle number. We have 2 middle numbers, and we have 36 right here, and we have 37. So we have 36, number 25, and 37. So if we average 36 and 37, we get 36.5. So I'm just going to type that in. But, of course, Excel does that for us. So I'm just kind of telling you what the median is. It's the middle number, but the numbers have to be in order. And we get 36.5. So again, if you want to do it, just so you know how to do it without Excel, it's the middle number. And if we have an even number of numbers, you take the average of these 2 middle numbers, 36 and 37. So it'd be 36.5. Okay, and then we do the variance. Now we don't use the variance pretty much at all, but if you see that there's 2 variances, there's dot P, which is the population. See, it calculates the variance based on the entire population. So the P is for population. We just have example most times, so we use the S.S, variance.S, and what that is, it's a standard deviation squared. So I don't really use that very much. We don't use it in real life. I don't really use it at all. So this is the variance for the sample. And then we could do equal standard deviation. Dot P right here is again for the population. Dot S is for the sample. So I'm going to do dot S and pick my numbers. And again, stop me if you have any questions. And press enter. And that gives me the standard deviation of the sample. So if you notice, what's this, if you square this number 9.03, that means multiply it by itself. 9 times 9 is 81. So the variance is the standard deviation squared, which means 9 times 9 or standard deviation times itself. Okay, now when we talk about percentiles, or I guess range, we should talk about the range. The range is the highest number minus the smallest number. So if we look, since our numbers in order, my highest number is 50 and my smallest number is 20. So 50 minus 20 is 30. So I can just put 30 here. I is the highest number minus the smallest number. So let me go back to my whiteboard. Because I want to talk about percentiles for a minute. Okay, so a percentile is, suppose I want the 30th percentile. It's the number for which 30% of the data is below, and it includes that number. So some books don't include the number, but our book does. So when we do this in Excel, it's .inc for include. So if we want, say, let's do the 30th percentile in Excel. So I'm going to do equals percentile. See, the EXC is a command, but that is not including that number. Okay, that means 30% of the numbers are below that number. If we do the 30th percentile, we want the INC. So we want to include, the INC means include. So if we use this in Excel and pick our range, and I'm going to do it longhand too, so you know how to do it longhand, and we'll compare our answers. So I want to do select our array, and then K. K is what percentile we want. We want the 30th percentile, so 0.3. For 0.3 is for 0.30 or 30%. So we get 29.7. So that means below 30% of our data, 30% of our data is below 29.7, including 29.7. Now let's do it longhand, just to see that we probably won't get the same answer, but we actually, we will, because we have, let's see, from in our data right here, 15, we have 15 numbers that are below 29.7. So 15 of our numbers are below 29.7. Let's do this longhand. So the formula is I over I equals, let's see, erase this. The percent times the number of numbers. Or our percent could be like K over 100 times N. Okay, so we have the 30th percentile, or 0.3, times we have 50 numbers, and we get 15. So the number, and that just gives us the position of the number when we do it longhand. So the reason we use I, okay, the reason we use I here is that it stands for index. And index stands for the position. So 15 isn't our 30th percentile. 15 is the position of that number. Now, if you read the announcement kind of showed you how to find a percentile. It said if you get an integer, then you have to, which we did, 15. We didn't get 15.1. We didn't get 15.7. We got just 15. If you get an integer, you have to average that number in that position with the next number, with the next highest number, or next highest position number. Well, that's not good. With the number in the next highest position. The number, sorry, in the next position. So in this case, it's telling us that we have to average the numbers in position 15 and 16. And that will give us our 30th percentile. That 30% of the numbers are below or including that number. So let's go back to Excel. And so let's see, if we look at our numbers, they're in order. Here, I'll blow them up a little bit. So position 15 is 29, and the next position is 30. So we want to average 29 and 30, and that would be 29.5. So longhand, I'll just say longhand. Doing the work, we get 29.5, and using Excel, we get 29.7. But it's still saying, because we don't have decimals in our data, it's still saying that the 30th percentile, you could say, is either one, because 15 numbers are below 29.5 or 29.7. So if you do it longhand, you're going to get a little off. And the reason, okay, here's the reason of the, let me go to my whiteboard. Excel, well, I don't really need the whiteboard. Excel uses a calculator and actually calculates out the exact value. And if we use the formula, it's just saying, you know, take the average between. So you're always just going to get the middle number. You're not going to get the exact number, but you're still going to get the same result. That 30% of the values are under 29, basically, in our data. Let me go back to Excel. Okay, so let's talk about quartiles though, and see how far we're off when we do quartiles. Our quartiles are 25% of the data. Quartile 1 is where 25% of the data is below that number or equal to that number. So if we do quartiles, we could either do percentile, including, and take all our numbers and then we want the 25th percentile, 0.25, and we get 27.5, or we could do quartiles, including, take all our numbers, and we use a 1 because we want the first quartile. So we would just put, if you look at this one, if you look at what they're telling you to type right here, it says 1 is the first quartile or 25%. So if you use the quartile command, you just press 1 and we'll get the same answer. So this is using percentile 0.25, and this is using quartile 1. You get the same answer. So that means 25% of the scores are below 27.5 or equal to 27.5. Okay, that's what that means. If you want the third quartile, that's 75%. You could do percentile equals percentile, including, so INC, and then you would do 0.75. Or you could do equal quartile, including, take all your numbers, and then in this case you would put 3. The third quartile, if you look at 75%, so then you would just type in 3 and you should get the same answer. So the score of 43, 75% of the scores over here should be below or including 43. Now, if we do it longhand, let's go back to our whiteboard, quartile 3, then you would do 75%, 0.75, or that's 75 over 100 times 50. So that would be using the formula. Equals 37.5. You would round up to 38. So if it's not an integer longhand, you round up always to find the quartiles. So position, this gives us your position. Position 38 should be our, where 75% of the data is below or equal to that number. So let's go look at Excel. And position number 38, let's look. 38 is 43. So it's the same answer right here. It's the same answer that we got when we used Excel. We got 43 for quartile, let's see, quartile 3. 4%, 0.75. And then the IQR, the interquartile range, the IQR is just Q3 minus Q1. It's just the middle 50% of your data, right in the middle. So if we want to do that, we just go equals 43 minus 27.5, depending on if you do it longhand or you use Excel. I don't have a preference, whichever one you want. And you get 15.5. So 50% of the data, which is the interquartile range, is, well, the range would be 15.5. Okay, so I think that's all that you need, except for I've been talking a lot. So let me go back to my whiteboard. Any questions on that? Okay, I'm just looking at the questions in the assignments. And Brandon, you asked me about the population parameter. Again, it's usually unknowable. You can't really find anything out about exactly about the population. So, but the parameter is the true unknown value, which we want to estimate using the example, and it describes something about the whole group. So that would be like the population mean, the population standard deviation. But the point estimate is just the estimate of that population parameter. So a point estimate could be like the sample mean that describes the population mean. Again, it would just be an estimate, our best guess.
Okay, I get it. Thank you.
Okay, looking at the questions, I kind of answered stuff on the questions. Does anybody have anything else you want me to talk about?
I'm good to go now, I think.
Okay, well, you can get in touch with me. So if you get stuck.
Yes, ma'am. I have your contact information saved from last week.
Okay, well, here it is again. Text me, call me. I don't want anybody struggling in here.
Yeah, for me at least, it's seeing it in action that I need, because like I said, that's why I do the problem in the textbook first, because it helps me work through the concepts. Because sometimes, just like when they start doing like the I equals and all of that stuff, it just sounds more involved than it really is when you really start plugging stuff in.
No, I totally understand. Yeah, I totally get it. I would also work to connect. I would also like print out, or if you have a printer, the assignments or the discussions, because that's actually, what we focus on. There's so much in the text that we don't cover. And if you look at the assignments ahead of time, kind of work backwards, that kind of helps too. So you know what you're looking at.
Okay, I'll try that moving forward.
Well, I mean, it's just a suggestion. I would, I'm not saying do the assignments. I'm just saying print them out and just look at them. So that means what, if you end up reading something or you need more help with, then, it just helps more focus it because there's so much there. So that's just a suggestion, but you can please call me or email me or text me and I will help you.
Thank you.
Kimberly, are you okay? Any questions?
It looks like, hello, when I chimed in, it looked like they had already asked what I what I was going to ask, and you were on, and I was like, oh, okay, great. I'm not the only one in that same part, kept getting stuck.
Okay. Well, let me know if you need help, okay?
Okay. Yeah, it's a little better.
Good. And I'm glad you got everything straightened out.
Oh yeah, I was about to have a heart attack last week.
Brandon, are you okay? Do you have any questions?
No, I'm all set. Thank you very much.
Okay, don't hesitate to call me or text me or just contact me if you have questions.
Will do. Thank you.
Okay, I can get on anytime if you need help. All right, well, you guys have a good evening.
You too. Thank you.
You as well. Thank you.
Okay,
Bye.
bye-bye.
Bye. Yeah.